All right, so I'm going to go ahead and get started on a React lecture. If you guys would, close anything else that you're working on. If you have anything else open that's not notes or the lecture itself. Just to give me your full attention, please. And we'll get started. So this is primarily React theory. And so you're going to notice the first 6 objectives. If you look at the general objective, implement React as a front-end web application. But then if you get into the theory, it's a lot of just information. It's a lot of what I would call the fundamental React principles. Like, this is the foundation of React. And the first 6 bullets are all that React theory, the React foundation. I've done this with you guys before, so let's do this again. You know, I like to do this. These objectives, I'm going to tell you what I'm going to tell you, and these are the objectives. This is what we're going to talk about today. Objective 1, objective 2, all the way through 7. And then at the end, and then I'm going to tell you, right? But then at the end, I'm going to have you tell me. Like, I'm going to have you tell me, if I ask you to describe React components, you're going to tell me about React components at the end, right? So if you jump ahead on the slideshow, you will see that there's a review slide at the end, and that's how we're going to begin to sink this information in, right? I'm going to ask you to tell me about what you know, and as you guys remember, as I've done this before, I'm okay with awkward silence. I'm okay with you getting the answers wrong. That's part of learning. It's okay. But I will make it as awkward as need be until some of you at least give me a shot at an answer to these theoretical questions. Because I will be asking you these things, it is my advice to do what so many college students don't do anymore, and take notes. Because if you're taking notes, that will help you regurgitate the information that I spit back at me, right? And that will help sink some of this information into memory a little bit, okay? If you actually do the unthinkable and take notes as a college student, as I say that sarcastically. So let's go through the objectives. We're going to describe what is a React component. So we're going to get into these foundations of React. React is made up of components, and we're going to get into what is a component and why do they exist. We're going to summarize JSX. What is JSX and what are its rules, right? So JSX it's a language, and that language has rules. So we're going to dive into what is that language and what are its rules. We're going to talk about these new terms called state and props. And so React has state and props. It's just commonplace in React nowadays. So we're going to have to dive into that. I'm going to ask you to differentiate between declarative programming and imperative programming. Anytime you learn about React, you learn that it's just a little bit different than what you might be used to. And so we have to break down into these different kinds of programming languages and figure out how React fits in. We're going to talk about the virtual DOM. I'm going to ask you to discuss the virtual DOM and really what is a virtual DOM and what are its benefits. The VDOM, if you will. We're going to learn that React is a single page application, or an SPA. And I'm going to ask you to talk about the benefits of a single page application. So what are the benefits of an SPA? Like anything, there are benefits and cons, but I'm going to ask you to get familiar with the benefits. And then we're going to actually install React and begin to hello world it, right? At the very end, we're going to do hello world React. You guys have already done hello world React. In fact, by this point, you guys did React in your first semester. You've done React a little bit this semester. I would call what you've done so far as kind of like you were just tossed in the deep end a little bit. But now we're going to get into the weeds a little bit more, right? So hopefully some of these concepts can become more clear if you were just coding a little bit before without knowing what you were doing. Hopefully we can clarify what it's all about. Everything is about components in React. You guys obviously have taken a C# class. And in C#, you learned about classes and objects. And you learned in a programming language like C# or Java that object-oriented programming is you make reusable chunks of code. And it's what it's all about, is creating reusable chunks of code. So when you have a legitimate programming language to build software like C#, and you want to make your code reusable, because there's a lot of benefits to reusable code, you build a class, and from that class you build objects. Okay, so this is nothing new to you guys. You understand the benefits of using code, right? If you have a working class, right, no bugs in that code, you can reuse that over and over and over. You can begin to understand that code very well because you code it once and you reuse it many times. Okay, so that's in traditional programming. Well, developers at Facebook who made React, by the way, React was developed by Facebook in 2013. It's only been around 12 years. All right? There's something to be said about that because, even the most seasoned React expert in the world has about 12 years of experience with React. It's not that, hasn't been around that long. Anyways, developers at React, they made what are called components. Components are reusable chunks of code that you can use on the front end. And I guess I should start with this idea that you guys, I believe, already know. React is your front end of your web application. All semester long, we've been working on the back end. We've been working with the database. We've been working with the server-side code, with Express, right? Mongo, Express, Node, all of that is on the back end. React is now on the front end. Okay, so Facebook developers, they made a new JavaScript library. They called it React. And everything in React is components. Components are reusable chunks of code for the front end. So you look on the slide there, it says components are reusable blocks containing the user interface, the UI, and logic. And so when I think of a component, like you guys are all familiar with HTML, right? And obviously you should understand an H1 is a heading tag, right? This is an HTML element. Well, in React, now we get to make our own elements. We get to make our own, but they're not called elements, they're called React components. So you can have, as you could see here, you could have on the slide, there might be a cart. It's kind of like making your own tags, kind of like making your own HTML tags. Well, what's in that cart? What's in that cart tag, you get to define. And it's reusable. You could use a cart once or you could use it 10 times over. Okay, you could have one cart or you could have multiple cart tags. Just like you can have multiple headings, you can have multiple carts. Okay, so just kind of tying it together, everything that I'm saying, a component is essentially making your own HTML tags, and you know that tags are reusable. It contains what does the cart look like, right? That's the UI. What does the cart look like, and how does it work? What's the logic of the cart? So that's what a cart is. And on the slide, a couple more things to kind of pull out of that slide is that you can nest components within one another. And so I think they have a product list. So you might have a tag, a component for a product list tag, and inside of that you have a child tag that is a product. So you have, just like in HTML, you have parents and you have children. You have children nested underneath parents, and that creates that hierarchy that's called the DOM tree, right? The document object, the DOM tree is all the elements and they're nested within it. So I could have a product, another product within it, and then you close the product list. Okay, so point is you make components. Components can be nested within one another. Components are the UI, what does it look like, and the logic, meaning how does it function. So on the slide, and I guess I can go full screen with this, you're building user interfaces. That's what we're doing. We're building user interfaces. And again, I need to kind of step back. The problem that Facebook developers were solving, why did they make React in the first place? Has anybody not had a Facebook account? Has everybody at some point in your life had a Facebook account? The exact opposite. Facebook's site, if you think of Facebook and how much complexity there is, there's a chat feature, there's a marketplace feature, there's your wall, there's all your friends' walls, there's a marketplace, you could date on Facebook. There's a million things that you can do on Facebook. Yeah.
But that happened with React before, it was just really simple and really plain.
As Facebook evolved in all that it could do, the website itself just became more and more and more complex. So what did they do? When you want to solve a complex problem, you break it down into small, chewable bites. You know what I mean? And so you start having, let's just have a small component that solves one problem. Maybe this component is the chat component. And you have a footer component, and a header component, and a sidebar component. And so when you have a big complex problem, a big complex software, you break it down into small reusable components. And so that's what Facebook did. That was the problem that they solved. And so I have a screenshot here on the slideshow. You could see these different components and how they come together to make up a UI. And so on the code, and we're going to get into what is this code that we're looking at, because it's not quite HTML and it's not quite JavaScript. It's something a little bit different. But you can see that there's a video tag, if you will, or a video component that's the parent. And then as a child of the video, you have a thumbnail. As another child, you have the like button. Okay, so again, you can think of the term of the parent, which is the video element. And then the parent has a couple of children, one thumbnail child and a like button child. And these components come together to give you the output that's on the right. That's a simple video element of video on the browser, a heading, a subheading, and a little heart icon for the like button. Okay, so you can see how these components work together to give you a user interface. And those components combine together to give you your web page screen or your web page app and so forth. At the end of the day, components historically were made with JavaScript classes. Okay, React version 17, they changed. And now you no longer make components with JavaScript classes, you make components out of JavaScript functions. And so the first sentence right there, React components are JavaScript functions. And so when you're coding JavaScript, we are coding JavaScript functions and making components out of them. So that's an important thing to know. Before they were functions, they were classes, but nowadays, if you're doing any modern React development, it's always function-based components. Okay? I've been doing React for about 5 years, and I have always done function-based components. I've never done class-based components. It's been around long enough. And so you can kind of see, here, it's JavaScript. We're just coding JavaScript. So can you show content conditionally? Well, yes. If the user is logged in, say welcome user. Otherwise, show them the login button, right? So you can show content conditionally in React because it's just JavaScript. If you can write an if-else statement, you can show content conditionally. Can you display a list of items? Yeah, you know, there's a JavaScript array. You put your items in an array, and then you map over your array. So the statement on here is learning React is learning programming, or is learning JavaScript, I should say. Okay, so yeah, takeaway from this slide that I want you guys to have is that React components are just JavaScript functions. Do not let components intimidate you, because if you've written a React function, or excuse me, a JavaScript function, which you all have, you've essentially you have the understanding to write components. Now, if you're looking at this slide, I kind of pointed out the language there kind of looks like JavaScript and kind of looks like HTML. And that language that these Facebook developers, they call that JSX. JSX stands for JavaScript and XML. But if you look at it, it's really JavaScript and HTML. Right? You can all recognize the HTML tags in there, and you can all recognize the function, the JavaScript. The reason for the X in the XML is that XML, before JSON, XML was the standard. And so what does JSON do? JSON is used to transport data. You're going to send data from here to there, and you're going to send it across in a JSON format. Okay? Before JSON was XML. You would just send data from point A to point B, and you would put it in XML tags. And XML had a bunch of rules that you had to follow. So JSX is JavaScript and HTML combined, just JavaScript and HTML, with the rules from XML. So what are the rules from XML? So you can kind of see JSX is HTML and JavaScript, and the rules is that you need one parent element. So XML has this rule, and you can't avoid it in JSX. When you're writing JSX, you need one parent element. So if I look at this slide you see the keyword return, and then inside of there you see the first tag, which is a section tag. That section tag is your one parent element, right? All the other elements have to be nested inside of one parent, and that is the rule that you get from XML. It's also a very strict rule in XML that every opening tag must have a closing tag. Okay, and you guys remember this a little bit from HTML, and I'm kind of running out of space, I'm going to erase here. I'll give you a little history of HTML. In HTML4, there was like a BR tag, line break. And in HTML4, you could get by with just doing a BR, and that would cause a line break in your markup. And then after HTML4, a language called XHTML came around. XHTML stands for XML. And they said, you know what? That line break, now we're going to require the // because that XHTML, again, you get the X from XML, was kind of like a strict HTML. And you couldn't get by any longer with just an opening tag. You had to have both an opening and a closing tag. And so whether the closing tag was in the in the opening tag itself, or it was a separate closing tag. Another self-closing tag that you see a lot is input. Image. These are all tags. And then now with HTML5, sometimes you can get by with just having, not that it's a good practice, but you can get by with it. So when you add the X, whether it's in XHTML or you add the X in JSX, you just have XML rules to follow. So one parent, and every tag must also have a closing tag. The thing about JSX is that our web browsers, Chrome, Edge, Firefox, they do not understand JSX. So we're not, from the server, we're not going to send JSX to the client. Instead, you essentially, what they call transpile, but I think of it as just compiling it out of JSX into HTML, CSS, and JavaScript. So JSX is not understood by the browsers. So the servers don't send raw JSX down. You have to essentially compile it out of JSX into HTML, CSS, and JavaScript. You guys have done that process. You guys have transpiled JSX into HTML, CSS, and JavaScript. And the command npm run build. You guys remember this command? How many times do you run npm run build? Many times. Many times. You might not have known exactly what was happening, but it's taking your JSX and essentially converting it into HTML, CSS, and JavaScript, because you're writing JSX, but that's not understood by the browser. So you have to get it out of JSX and get it into a format that could be sent from the server to the client. Now, I put the file extension because we're learning TypeScript. So every time I've ever taught this class before, the file extension was .jsx. Like that was the file extension of the source code that we were writing. However, now we're writing with TypeScript, so the file extension is .tsx. So the J's were replaced by the T because it's TypeScript, not just JavaScript. And here's just a little snippet of what JSX looks like. You can kind of see JavaScript, and then you see the keyword return, and then inside of that keyword return is where you see a little bit of HTML. So you see the JavaScript, you see the HTML. And then inside of the HTML, when you got the braces, you got the word title in there. That title is a JavaScript variable. So you're kind of injecting a variable into your HTML. So again, it's HTML and JavaScript, and they're playing together in this language called JSX. Questions about JSX? Comments, concerns? Is this clarifying a little bit of the code that we've been writing before? Is it making a little bit more sense? A lot of times I just toss you into the deep end and tell you to swim, but now it's like, oh, okay, maybe make a little more sense. Okay, so you know what components are, and you know that you write JSX to make components. And those are the two kind of concepts so far. Maybe one of the more complex things for a beginner in React is this idea of state. But the way I think of state, in like the most simple way, is state are your variables. And you guys know variables. You've done variables in JavaScript, you've done variables in C#, you've done variables in everything. So what do you store in variables? Well, your data. You store your data in variables. They call it state in React because the language that's often used is you'll talk about what's the state of the web page. What's this current state of the web page? Well, when the web page loads, what's the state? Well, there's no information on the page. Right? But as you start to fill in the information, you put in your first name, you put in your address. Now there's state on the page. You have information. on the page, right? And then you refresh the web page. Does that state persist? Does that state stay there? Or do you lose the state? Right? So that's just the language that they use when you're talking about data on a web page. That's just the industry lingo. Okay, what's the state of the page?
So that's when we put like the use statement like on top of the JSX file?
That's where you use, that's called the use state hook, and that's how we're going to create state in React.
Okay.
Yeah. So the use state hook, they call it hooking into your state. So use state is a function that allows you to create state and work with state. It's how we create variables for our web pages in React. That's exactly right. And it's called with the use state hook. And that's actually what I have in the code there on line 1. You can see import use state from React. So I'm bringing in what's called the use state hook. And then there's one variable on line 8 there. Line 8 is a variable called count. And this is just a counter, right? This is like the template. You've all seen this count hook that you just, click the button and the count goes up by 1. That's all it does. It's a very simple example of state, but it's an example nonetheless, right? So, so the textbook definition here, state can hold any kind of JavaScript value, so any data, any value, including objects, but you shouldn't change objects that you hold in React state directly. I'm gonna clean this up. I'm just reading for a second. Instead, when you want to update the object, you need to create a new one and then set the state to use that copy. This is a weird thing in React, and I can explain why. In JavaScript, you make a variable, right? You call let x. X is our variable. You can set x equal to 5, and then a line later you set x equal to 10. You do the equal sign, right? That's the assignment operator. You first assign x equal to 5, and then a line later you just change the assignment equal to 10. You are reassigning the value of x. You're changing the value of x directly. Okay? That's actually not what we're supposed to do in React. So notice the variable on line 8 is called count. So you might just say, okay, well, count equals 5, and then on the next line you say count equals 6. And you would think that if this were just JavaScript, that would work. And in fact, that technically works, but what you would notice is that the web page itself would not update count to 6. Okay, so I kind of stuttered through that paragraph. But what that paragraph essentially says is you cannot directly modify your variables just by using the assignment operator. If you're going to modify your variable in React, it's done with a very specific method. So to change your variables in React, notice on line 8, there's a method. You might not recognize it as a method, but it's called setCount. So they call it a mutator method because it mutates the variable count. It changes the variable count. So we are not, the big red text there, it says treat state as read-only. That count variable is treated as read-only. The way that we're able to modify it is through that mutator method. And then there's one more layer of complexity there. If you want it to go from 5 to 6, when you want to update an object, you start by making a copy of the existing object. You make a copy of it and then update the copy. You don't modify the object directly. So even as setCount, you essentially get the current count, a copy of the current count, and add 1 to it. So it's weird because you don't modify count directly. Remember, count, you're supposed to treat it as read-only. we're not going to directly modify count. We're going to copy count and then modify. So you're modifying a copy, you're not modifying the variable directly. Now, why is that? It's because what we're going to get into, this whole virtual DOM thing, React handles the actual updating of the interface for you in a very efficient way with this virtual DOM. And so you're only modifying the state through these very specific methods, and it's going to basically do an update of the page very quickly because of that. So like, what's the benefit of this complex nature, right? The benefit that you get out of this is fast page refreshes, fast page updates, if you will. Okay, and I do have a link to the article there on React Docs on to dive a little bit deeper, because this is one of the harder topics for beginners. And I've been doing this for 5 years, and it's still a little strange because you're so used to having a variable and then just updating the variable. But you don't do that anymore. You make a copy and then you make a change to the copy. And that's how you're supposed to properly work with state in React. Okay, state is your data, the state of the page. And we have this thing called props. And I kind of showed before how components can be nested within one another. I want you to just imagine a component inside of a component inside of another component. You just have this tree of components. You might have 5 components deep. So like this hierarchy, right? You got 5 layers of components. And what props is short for the word properties. But it's how you send data from the parent down to the children. So if you want to send your state, when I say data, when I say you're sending your state from parent down through the children. And so when you have like 5 layers like I was talking about, and you send data from the top layer all the way down to the bottom 5th level, that's called prop drilling. You're drilling your data down. Prop drilling. And it's not every React developer's favorite thing to work with props and prop drilling. That's probably a criticism of React. And they have entire libraries that kind of simplify state management. But it's a good thing to learn for beginners, how to send props down through the component tree, if you will. Because then when you learn a tool to kind of simplify it, yes?
Are we going to talk about use context versus like prop drilling?
Yeah, so there's many hooks, and use context is one hook that helps with state management. And so the answer is yes.
Okay.
We're going to get there.
Like, I hate use context. I don't get it.
Yeah. And so today we're not getting into use context today, but we definitely do in the class.
Okay.
And so yeah, props, sending data down from parent to children. It's a one-way. You can't send data up. You can only send data down. So it's one-way. What do you call it? Unidirectional, one-way sending of the data. So in the code chunk, you can kind of see the component for a profile. Profile would be the parent, and then avatar would be the child. And so through props, each avatar component has its own size and has its own person object, right? That's the parent. Then on the child side, the child code would be the avatar component. Notice how on line 3, in that middle column, we're looking at the avatar, and it receives the person data, and it receives the size. So the person is an object, the size is just an integer. And you see the curly braces there, so it's doing a little object destructuring, right? We're destructuring the props object. So you send it in from the parent, goes down to the child, and then you could use the data in the child, and then the output is kind of in the third column. You actually get the image to show the image size, the alt attribute, and all that fun stuff. Okay, but simply said, props is sending data from the parent down to the children. Okay, really common thing that you do with props is you send in, like if a user's authenticated, your children probably need to know that there's a login user, right? Because if the user's not logged in, you're probably not displaying certain content, right? So that's a really common use case for using props, is like, hey, is the user authenticated to the website? And we'll definitely do that. All right. We're coming up on an hour of class, so one more slide, and then we're going to take a break. One more concept. Okay, 2 slides, one more concept. And anytime you learn about React, you will learn that React is referred to as a declarative programming language versus an imperative programming language. And so here's the example that I learned that I thought was just a great example. And you guys understand declarative versus imperative. Even these are new terms, you understand it. So here's the question for the class, right? I give you the task to make or to get a sandwich, right? So you're going to learn this in the context of, in the example of a sandwich. So if I say, hey, go make a sandwich, okay? You're probably going to start off with an ingredient list, like what do you got? What is the sandwich made up of, right? And then you might follow a set of instructions. You know, layer the buns, put the mustard on the buns, then you put the lettuce, then you put the tomato, then you put the meat, then you put the top sandwich on. So if I give you the task of giving a sandwich, you guys might have answered that with how you would make a sandwich, right? And you would give me a very detailed step-by-step how to make a sandwich. Okay, those would be imperative. That's the imperative way of making a sandwich. However, if I gave you the task of getting a sandwich, some of you might have thought, well, why wouldn't I just go to Jimmy John's and say, give me a deli sandwich? Well, right. So, but there's 2 ways of getting a sandwich. Way number 1 is follow a detailed list of instructions. Do this, do this, do this. That's the imperative way. That's how to make a sandwich. But some of you might say, hey, I got to get a sandwich. I'm just going to go to Jimmy John's and I'm going to tell Jimmy John's what I want. Right? So what I want is a deli meat sandwich with mustard. So in coding languages, right, the how, the languages that describe the how are referred to as imperative. Vanilla JavaScript is imperative. You are very detailed. Document dot, you guys remember this? Document dot get element by ID, right? You're selecting the element called footer, document dot get element by ID footer dot inner HTML equals, and then you put your content. That is a very detailed step on what part of the document are you updating it and how are you updating it, right? So traditional JavaScript is referred to as imperative. It's very detail oriented, right? React is not that way. React is referred to as a declarative. You're just saying, hey, this is what I want. This is what I want in the page, and then it's up to the language to kind of figure out the rest. Okay, so going to Jimmy John's and just ordering the sandwich, that's kind of what we're talking about here with React. Okay, you're just telling React what you want. Okay, now what does that look like in code? Does that make sense? Imperative languages are the languages that are very detail oriented and they describe how to do something, whereas Declarative is just describing the how. Or excuse me, the what. I had it. The what. Okay, I just want the sandwich. So there's two ways of getting a sandwich. Okay. So React is declarative. So it's a little bit different way of thinking. So here's the code chunk. And we already worked with state. So we could see up at the top, we declare state. And you could see my comment, right? So I got a little comment. It says, hey, in order to define or to work with declarative programming, we're going to start by declaring a little bit of state. And then down at the bottom, where it says right here, step 2. This is declarative rendering. You describe exactly what the UI should look like based on the current count state. You don't write code to directly manipulate the DOM. Instead, React is kind of handling it for you. So all we're really saying here is that on this button, on this HTML button, we're just saying, hey, I want you to put the count in this button. That's what I want. I'm not going into the DOM and saying how to do that. I'm just saying I want this number on this button. That's what I want. Right? So that's the what versus the how. Benefit to this. What's the benefit to this? What do you think the benefit might be? You don't have to do it step by step anymore. Exactly correct. Why is that a good thing?
It doesn't take up more space.
Space.
Time.
Closer. Speed. The speed of updating your website. So imagine this. JavaScript, vanilla JavaScript, gives you direct access to updating the DOM. 1 million JavaScript developers given the same task will solve it 1 million different ways. You've all seen that. You all solve it different. Same problem, and you're going to solve it differently than your friend. Right? Inherently, when that happens, same problem solved 1 million different ways. Some ways are more efficient than others. Right? Some ways are more efficient than others. Which means there's 999 less efficient ways and one most efficient way. Kind of thing. Okay? So in React, you don't directly update the page itself. Instead, the developers who made React, they handle it for you in a very efficient manner. You're not going to write slow, inefficient code this way, is the theory. Right? You just say what you want to achieve, and they handle the how, because again, there's many ways to handle the how that's slow and inefficient. They handle the how in a very fast, efficient manner. Right? So that's the benefit of writing declarative code. You just say what you want. And by the way, like when I first learned this, I was kind of intimidated because this is a different way of thinking a little bit. But HTML is the same way. Like you're just declaring I want something. Like in H1, you don't really say what font size that is. It's just a big font. Like, and it's just bold, and you just kind of declare I want the H1. So HTML is declarative. You've coded declarative languages before. My point is, don't let it intimidate you, right? CSS is another declarative. You say I want the color green. Now you can go in and specify a very specific shade of green. Don't get me wrong, but at the end of the day, you have a class, and you tell that class to be a certain shade of green, and then the web page just renders it for you. Like, you've written, SQL is the same way, right? If you guys have ever written a SQL select statement, you just say, give me the customers who have spent more than $1,000. You just give it what you want. I want customers who have spent more than $1,000. That's what I want. Figure it out and give it back to me. So those are examples of languages that you have coded that are also declarative. But every time you talk about React, they always point that out, that this is a declarative language and it's a little bit different way of thinking. Frankly, you could, as far as I'm concerned, you could skip that theory, because did you learn that HTML was declarative before you learned HTML? Not really. You just learned HTML, right? So I don't know how important that is, other than to say it is different than vanilla JavaScript. Yes.
It's just kind of unifying all three of the languages, and they're all declarative.
They're all declarative. Yeah, and the point is, don't let it intimidate you because it sounds different, anything like that. So that's declarative programming. That is React. Let's go ahead and take a break. My watch says 1:30. If you guys want to take 10 minutes. Okay, let's resume. And so in order to begin to understand the virtual DOM, we have to understand the traditional DOM in itself. And so you all have taken a JavaScript course, and you would have learned in this vanilla JavaScript course that DOM stands for, remind me, what does it stand for?
Document object.
Document object.
Machine material.
Close. Someone else. Document object.
Manager.
Close.
Markup.
Nope. Model. Document object model. Okay? But I don't think that really speaks clearly to beginners what it is. Right? Because if you can, so often, whatever. So model. Another word for model is a picture. Right? So if I were to translate this, it is a picture. It is a picture. M would be picture. The document is the HTML document. So really it's the HTML document, the HTML. So, the file, .html. The HTML file in a picture represented by objects. And so what are the objects?
The headers.
Yes, the tags. So there's just a picture of your HTML in a tree. That's what we're it's a tree-like structure. Right? You've seen those tree-like structures, and so you got a body, and inside the body you got a head and you got an HTML document, and then inside of the HTML document you have a head and a body, and inside of the head you got a title and a link, and then inside of the body you got a header and a main, and you got a footer. And so it's how do you draw that on a picture, right? And it is your browser just has this DOM tree in memory so that it can change your HTML. Right? When you script the DOM, it's changing the HTML with JavaScript through this DOM tree in your browser's memory. So it's a picture of your HTML objects in your browser so that you can use JavaScript to basically change the picture and change the HTML on the page. Okay? In the old days, updating a content on a page, and I don't know if you guys were around long enough to remember, before Google Maps, there was MapQuest. Anyone remember MapQuest? Yeah. And if you would go to mapquest.com in the early days, and if you just wanted to zoom in, right, you'd click the plus icon to zoom into a map, the entire page would refresh. And that was a problem because that's a client going to a server, the server responding, and it's slow.
That was back on dial-up too.
Back on the dial-up days, it was slow. And so to update a page, instead of doing like a full page refresh, right, you just, let me update a part of the DOM. Update it, and they came up with, Ajax to just update a part of the page. And so it doesn't have to require this slow page refresh. And so the virtual DOM is kind of the answer to fast page updates. And so I bring up MapQuest to say, hey, that was an example of a web page that had a slow page update. You simply zoom into a map and it just really slow to update. When you allow vanilla JavaScript developers to update the DOM in any way they want, that updating the traditional DOM using JavaScript is even perceived as slow nowadays. Right? In React, they have this, it's just built into the system. You don't have to code anything out of the ordinary. It's just a way to update the page by simply what part of the page needs to be updated, and you update that part of the page, right? And so the virtual DOM makes page updates fast, performant. So the process, okay. A little down into the weeds how this works. So you have an initial render, and I'm just going to go off the bullets. Step 1, an initial render. You're creating a VDOM blueprint. So step 1 creates the virtual DOM as a copy of the actual DOM that mirror the structure of your HTML, and it updates the real DOM to VDOM tree 1. So the entire VDOM is used to build the actual DOM. So now you've got virtual DOM 1 and you got the real DOM. Step 2, state is updated. React does not immediately touch the real DOM. It creates a new VDOM tree 2. So now you've got a VDOM that's not updated and a VDOM tree 2 that is updated. Step 3 is you'd run a diffing algorithm. What's the difference between VDOM 1 and VDOM 2? So you compare VDOM tree 1 against VDOM tree 2. And then finally, the reconciliation process. You find out what's the difference between the two DOM trees, and you identify a patch that is a minimal set of changes needed to update the real DOM. So just what's the difference between these two virtual DOMs, and then apply those updates to the real DOM. Why? Again, this is performance. This is simply, I think that's a safe answer. If I ask you, why does this feature exist in React? Your safe bet is performance. Now, React is a single page application. Wait a minute, Mr. G, I made a React app and there were multiple pages. I had a nav bar and I would click on this link and I'd click on that link and I'd click on the third link and my pages would be different. And I'd have different URLs. It would be /home, /about, /me, /whatever. I had different pages and it was a React application. What do you mean it was a single page application? Well, both things are true. You had different, what appeared as pages, but in reality, your index.html, that index.html page stayed the same, and you were using JavaScript to change out the pages, the page content. So React is a single page application, one HTML document, one .html, one JavaScript, one CSS. The JavaScript's just really big. It's a big JavaScript file. Okay, and I hesitate to talk about problems with React if I'm just talking about the benefits. I'm always talking about performance. But a common problem with React is the more components you have, the more JavaScript you're writing, the bigger the JavaScript download. That JavaScript download gets big enough on a slow enough internet connection, right? You've all heard of the blue screen of death, right? The blue screen of death on Windows is your Windows machine just goes blue with an error message. Okay, React, with those two conditions being true, a large React app, condition 1, and a slow internet speed, condition 2. With those two things are true, you get the white screen of death. The white screen of death means you load an empty HTML page, and while the JavaScript file is downloading, you're just looking at a white page forever. And it's a slow load, right? So that's a common criticism of React is on initial page load, when you have a slow internet connection, you get the white screen of death. It's a slow page load. So you can see there. Another criticism of React, okay? when you're looking at that HTML file, it's bare bones. It's kind of empty. All it really has is like a link to a CSS file and a link to a JavaScript file. There's no content in there. Web crawlers, like Google web crawlers that crawl your web page content for search engine optimization, they historically were not good at crawling your JavaScript files. So they're looking for SEO content on your HTML, and guess what? You don't have any content, right? So one criticism of React, slow initial loads, white screen of death. Another criticism of React, bad for search engine optimization, because your HTML, your content's just not there until the JavaScript puts it in, right? The JavaScript renders the HTML in, right? So those are criticisms. And that's why React is open source and always improving. And in React version 19, they now have, this is called client-side rendering. Client-side rendering is that large JavaScript file that the client has to render. But now in React 19, they have server-side rendering. And server-side rendering kind of fixes those two problems. Right, so React 19 has server-side rendering, and other libraries exist to help with that as well, like Next.js. Next.js is a whole other thing, but it helps fix that problem as well.
I was about to ask, Node, you can use that for Node and Express and all that.
Yeah. And so Next.js is another way, and it works with Node and Mongo. Okay, so back to single page applications. It's a single load. You load one HTML file and one JavaScript file. JavaScript updates the page without reloading. Benefit. Once that initial load is done, your web page is very snappy, very, very fast. Okay, you can go from page to page to page to page to page, and it's just client-side rendering. It's just swapping out content very fast. And so, like on a traditional HTML site, think about it. You load the home page, and then you say, give me the contact page. That's another round trip. You go to the server responds with the HTML and the CSS. Right? Then you say, give me the about page. That's another round trip. Client sends a request to the server responds with the HTML. Right? So those round trips are not considered fast. What's considered fast? Client-side rendering. You're just clicking. So it's always the example like, on Netflix, if you've ever used the Netflix website, I mean, again, initial load might not be the fastest, but once you're on there, you can click from movie to movie to movie, and it's just super snappy. It is just the fastest experience because it's client-side rendering. So there you go. Those are the pros of single-page applications. So faster navigation, that's a big one. Faster navigation and reduced server load. Once you get that initial request response, once you get that response from the server, you're not, these clients aren't constantly hitting your servers for more pages. So those are benefits, right? So again, what are the notes worth taking? I would say faster navigation on single page apps because of client-side rendering, and I would say reduced server load. All right, let's do the thing, okay? You guys feel free to do this with me. What I'm going to do is I'm going to install a React app. I'm going to use TypeScript and Tailwind, and we're going to dissect the different pieces of the app, okay? So feel free to do this if you wish. I'm just going to call this Lecture Code React. Yep.
Do you have to delete the front end?
Yeah, if on your projects, that's what I'm going to do. I'm just going to delete whatever I have, and I'm going to start over with the front end. Back end, I'm not going to touch, but I am going to start over with my front end.
And you have to press TypeScript instead of JavaScript.
That's right.
Okay.
That's right. Okay, so now I'm going to open this with VS Code. I'm going to start a new terminal. Now, there's a bundler called Vite. Vite will bundle your code. So like, for example, if you have unused CSS classes, it's not going to bundle your unused CSS classes into production. Like npm run build, that's going to be your production code. Vite will optimize your code for you in production. So whatever code you write, think of Vite as a bundler to minimize your code, to optimize your code. So we're going to use Vite. Vite is like big trend in the industry right now. So we're going to use npm create Vite at latest. And I'm going to hit dot. Dot just says current directory. You don't need to name a subdirectory here. Just put it in the current directory. The directory is the lecture code React. Okay, so I'm going to do that. Did I type? Oh, view. That's not going to work. I got the word view. Control C. npm create Vite at latest dot. Okay, the package name, if you just hit tab right here, it's just going to give you your folder name. I'm going to select React as the framework, and I'm going to select TypeScript as the variant.
Not TypeScript React compiler?
No, I just choose TypeScript. And then install with npm and start now. I'm just going to hit yes. So this is going to download the dependencies. As you can see right there, installing dependencies with npm. Did you choose a different option in one of those tutorial videos?
No.
No? Okay.
Wanted to know if it was like React compiler. It's one of the
Now we're just going to use Vite for the transpiling. Okay, so this does get it up and running on localhost. And if you want to learn more about Vite, I'm going to give you guys a good video to watch. You can read about more on the Vite website. Again, Vite's a big industry trend right now, using it. So there we go. Now, for the sake of this, I'm going to npm install. I believe you guys did this last week. Tailwind CSS at Tailwind CSS Vite. So a couple of Tailwind dependencies. Let's see. Okay, so we got Tailwind installed. Let me pull up my notes real quick. The next thing is on the Vite config. We're going to bring in Tailwind here. I just got to bring in the import statement. Okay, so I'm going to import Tailwind CSS from at Tailwind CSS Vite, and then bring in that method right after importing React, Tailwind CSS. Okay, so one import on line 3, and then we call a method Tailwind CSS on this define config. And then on my CSS, this is my index CSS. There's an index CSS and there's an app CSS. Index is kind of like your global CSS. I'm just going to delete everything here. And I'm going to add import Tailwind CSS. And we're almost done. So if I look at my index, and I look at my app TSX, okay, so here's my app CSS, app CSS. I think I'm ready to start using my Tailwind classes. So let me delete everything here. Now in React, this becomes class name. So notice the HTML attribute for class becomes class name, and npm run dev. And there we go. The Tailwind classes of 3XL, font bold, and underline are being applied. So that's how we install React. We got Hello World in React. And we're also bringing in... Now, let's look at the different pieces here on the PowerPoint. You guys, did I forget the most important thing here? Did I show you guys this? The most demanded front-end frameworks in 2024? Did I show you this?
No.
How did I show you this one? Did I show you? I showed you the Stack Overflow, right? And I said React.
Yeah, you should.
I showed us this one, but I didn't show you this one. This was number of jobs. So this is a devjobscanner.com, scanning open job listings. And this is in 2024. And so React had 126,000 jobs versus Angular 86 versus Vue versus others. So just speaking, 250,000 job listings. React is the most demanded front-end framework. That's kind of important, I think. Okay. So index.html. This is your entry point. This is the go. This is the start line, right? I ran a race this weekend. There was a start line. This is the start line for React. Notice all it does is it loads. All it really does is it loads the main TSX. This is your main component. The main component loads app. So really all main does is load app. In app, this is the singular component that we change the source code in. Inside of main, this is where we're importing index.css. Right? This is index CSS. All it is importing Tailwind. So again, we kind of start, where do we start? We start at index. Index loads main. Main loads index. Main also loads app. Cool. We have package JSON. This is your metadata for your project, right? Including your dependencies, including your start scripts, the start script, including the build script, right? TSC, your TypeScript compiler, and Vite build, right? So we're compiling and we're building with the build script. Here's our dependencies. Here's our dev dependencies. Vite config. This is a config file for Vite. tsconfig is your config file for TypeScript compiler. So you guys, I imagine we talked about tsconfig in the tutorial video last week. The source directory right here This is where 98% of your source code that you're going to write is going to be inside of source, including your JSX, including your CSS. Remember, JSX is JavaScript and HTML. CSS is just like it's always been, CSS. So most of your source code that you're going to write is inside of the source directory. Yes?
I wanted to ask, why do we have both like app TSX and main TSX? Like, couldn't we just like call like one of them and have
Is it necessary?
If you're having quote unquote multiple pages, so you can switch out which one is currently loaded, I imagine that.
Yeah, so let's see how it draws it out. A lot of times I understand, I mean, it makes sense too. Like, if you think about HTML, the first thing your parent node is body. And then a lot of times underneath that, you have a wrapper div. And it just gives a little extra layer of control to have two different things there. And so you could do things to the wrapper and not touch the body. So I've seen it before where it just gives a little bit more control. Like what we'll do as we bring in routing too, we might have React Router writing code in here. So again, I think you could do things in one you might not do in the other. Last but not least is public, and these are your static assets, like your images. Like this Vite SVG, this image will be made available in the root of the file. So your static assets can go inside of public. And then of course there's also the dist folder. So if I npm run build, and of course, it's not happy because I'm not using these variables. So let's delete these variables because we're not using them. And we learned that TypeScript is a little bit more strict than JavaScript. So now I run the build command. And what happens here is it transpiles, fun word of the day, transpile, your JSX into HTML, CSS, and JavaScript.
And that's what all the browsers would read it from?
That's what the browsers will read it from. So it converts whatever JSX we write into these other languages in a very efficient manner. And now we have this dist folder with index.html. Look what this dist folder, it makes a random GUID, if you will, for the JavaScript and a random GUID for the CSS. Every time you do a build, like let's look at FC and TK, if I were to rebuild, well, here's TK and FC. It looks like the same, maybe because it didn't actually change anything. Let's get rid of something here. We'll get rid of that. I thought there were different names all the time. And maybe that's not the case. So it ends in TK and FC. Oh, there it is. When you actually make a change, now the CSS has a different GUID and the JavaScript has a different GUID. Right? So every time you do a build, it's generating new HTML file names and new JavaScript. You do not want to open up this and change this. Like this source code, we don't touch. We let npm run build generate that source code. So the dist folder is for production. And hoo-ha. That brings us back to our slides. All right. You guys ready to be tortured with some questions? Hey, Ryan. He's your first question's coming to you.
Okay.
All right. How would you describe React components?
Components are reusable blocks containing both UI and logic.
Hey-o. Good answer. And what else can you say about React components?
JavaScript functions.
They are JavaScript functions. What language do you use to make React components?
HTML and JS.
And when you combine those two together, JSX, right? All right, Ryan, you passed. We'll just go up the row. If you will, to Sean. What are some of those JSX rules? So JSX stands for, let's just start with, what does JSX stand for? Bingo. And what is the X?
XML.
XML is correct. What do you remember of any of those XML rules?
You would make I'm picturing you when you make the elements.
Uh-huh.
So,
So every opening element must have a
closing
closing element. That is correct. That is an XML rule. So gave you a little lead there. What about, are you allowed to have multiple root nodes? Or are you only allowed to have one root node? 50-50 chance. One root node or multiple root nodes?
You can only have one.
One root node is correct. Right? Take a look at my screen. Line 6 and line 10. There's our root node. That's kind of a faker node, if you will. They call that a React fragment. It's just, hey, there's a rule in here that you have to have a root. So just make an empty fragment, and that's a cheater way, very commonly used in React, to abide by that rule of only having one parent. Thank you, Deshaun. All right, Brody, you get the hard one.
Oh.
How would you describe state and/or props?
State is like pretty much a way to set the variable type.
Yeah.
The way I see it's like a getter or setter.
It's like it's a variable, and you have
That's how you modify it.
That's how you So you have a mutator method to set the state. And can you modify a state variable directly, or do you have to make a copy of that variable and then modify the copy?
You make the copy.
You make the copy and modify the copy. Weirdest thing ever, because that's how React reacts fast and updates your page fast. All right, so that is state. What about props?
That's how you pass down from the parent page.
Yep.
I guess you could say to the children pages.
That's right.
They pass information.
That's right. And can you send props down and up, or is it just down?
Just down.
Just down. And what do you call it when you send it really far down?
Dropping it really far down.
Dropping it like it's hot. How about that?
Drop it like it's hot.
Drop it like it's hot. God, that is the dorkiest joke I think I've ever made. Prop drilling. I'm sorry, Nia. Nia knew. Nia, do you want to do the declarative versus the imperative?
Sure, we just open my notes.
Yes, yes.
Something about Jimmy John too.
So basically, declarative programming is the what, and imperative programming is the how.
The what versus the how. So which one is React?
React is the imperative way, right?
The declarative. Declarative. It's the what.
I was just reading my notes and I accidentally mixed them up, but
It's all good. So what are some imperative languages?
imperative languages.
The how.
So JavaScript
Bingo.
by itself.
Bingo.
JavaScript with XML, JSX is declarative because it basically unifies the HTML, HTML, CSS.
Precisely. And I love my sandwich example. I don't know if that really landed for you guys, but it's like, hey, you want to make a sandwich? The imperative way of making a sandwich is very step-by-step instructions, versus the declarative way of getting a sandwich is you just go to the store and you say what you want. I want a meatball sub with mustard. And then they do it and give it to you.
And when you said Jimmy John's, though, I was like, oh no.
Jimmy John's, Subway, you pick your favorite. So the sandwich example, I like it. Hopefully it lands for you guys. Oh, Courtney, I don't know, man. This is discuss the virtual DOM and its benefits. What's the benefit?
It makes updating the page faster.
Faster, yeah, that's the easy answer. It makes the page faster. And how would you describe the virtual DOM?
Essentially like a like a copy of like
Yeah.
the actual DOM.
Yeah, that's a good way of thinking of it.
Modified.
That's right. Just like a copy of the DOM. And then as the state of the page changes, you don't have to update the whole DOM yourself manually. It just, the virtual DOM just figures out what needs to be updated and updates the small piece. The individual element that needs to be updated. Or the couple of elements that need to be updated. Anna, give me one benefit of a single page application. I kind of gave two benefits that I highlighted, I tried to highlight, of SPAs like React. Remember when I asked for the benefit, it's always performance. Performance, specifically in this case, of navigation performance. Navigating from link to link on your site, just as fast as could be. Going from one link to the next link, very fast. Okay, it's actually this bullet right here, faster navigation. Because it's client-side rendered. All the JavaScript's there, you click the button, boom, in comes the new page. Very fast. Michael? Give me another benefit of a single page application.
After the initial load, it's easier on the server.
Easier on the server. So if you've got 1 billion users, they request it one time and then they leave the server alone. Whereas if you got 1 billion users and they're always making server requests, they're bogging down your server. Quinn.
Yep.
Well, we're down to the last one. Install React with Vite and describe the anatomy of a new React app. Well, I'll tell you what. Quinn, can you see my screen?
Yeah.
What is the starting point of the React app?
App.tsx.
Okay, that is correct. That is your first component. But what loads the first component is
Index.html.
index.html. So your main TXS is your first component, but that's loaded by index.html. We got some config files like Vite config and TypeScript config. We got some CSS files. We got our components. Public is for your static assets, like your images. The dist folder is for production. Node modules are your dependencies for the front end. You guys have been introduced to React. Good job. Well done. Thank you for your attention. I'll stop the recording. Oh, you just got to do a build if you don't have the dist folder. npm run build will generate it. The first lab is lab 0501. It is a shopping cart. You will build this. The problem with this, lab was I last did it with Bootstrap. I haven't updated it for TypeScript. So guess what? You get to figure out the styling a little bit here. There's a bunch of requirements for this lab. So a bunch of requirements. There is a screen mockup. And there's a getting started. So like these steps are to get you started. And there are 2 videos that I did this with vanilla JavaScript. I didn't do it with TypeScript, and I didn't do it with Tailwind. So those videos can help you get started. Kind of a code along, kind of not. But those some videos that will get you going on a React shopping cart. That's the first lab assignment. You have the rest of today and tomorrow to get those done. Sound good?
When is it due tomorrow?
No, let's do Sunday.
We don't have school tomorrow.
We don't have school tomorrow. You have Wednesday. Thank you. You have the rest of class today,